We're just gonna be, yeah.
Yep. Yeah, you could.
Yeah, just start my ceiling for a while.
That's good. That's good.
It's way too funny.
Oh wait, no, I gotta get you in there for the broadcast.
Yeah,
She's here. Oh, here, Sister Wilkinson.
Oh, I didn't care. Okay.
Just making sure.
Jeez.
Alrighty. Okay, we have the quiz open, everyone.
No, but you guys can start. It'll take 2 seconds.
It's okay.
No,
All right.
it's gonna take that from you, Paige.
Just because you're FaceTiming doesn't mean you're special.
Group leader. I mean ringleader.
All right, so
Yesterday.
question 2. Yes.
Yeah.
Given a 90% confident interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? We are 90% confident that the true mean heart rate is between 45 and 105.
Yeah.
Yeah.
Woot.
So that confused me. Did you guys take the what was it? There was like a problem, like a homework quiz or something like that. I think it was the last one. I missed it because it was like it said we are 95% confident that there's a chance of something, or like we are confident the true mean. I don't know. It mixed it up a little bit, and I missed it.
It's like either 90% of means will fall into this or something like that, or we are 90% confident that the true mean is within.
Oh, okay.
I think it can be either of those two because that's what it was on the homework quiz when I did it yesterday, and I got 100.
Show off.
No, I'm just saying I got it right, so it must have been right.
All right.
Yeah, I got 100. So I think I'm gonna run for the position of ringleader.
Okay. I'll hand it over.
Because I don't want that kind of responsibility.
Actually, yeah, that's terrible.
Oh my gosh. Okay. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 50 males to participate. The go-no stimulus required the student to respond to a particular stimulus and not to respond to other. 3. The researchers decided to construct a confidence interval to determine if the if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples, and they are approximate to see if they were approximately normal. Okay, so anyway, I can't read today. I'm like so out of it. Okay.
What? What?
So are the requirements satisfied?
Oh, I shrugged my shoulders, but you didn't see it.
I think it's fine. Like number. I mean, what? It's C.
Yeah.
Oh, okay. That makes sense.
Because they created QQ plots.
What's the central limit theorem again?
It's the one that says that if your sample size is big enough, then it's normally distributed.
Got it.
Yes. And what was the other one? Law of large numbers? Yeah.
One more.
Yeah, that's the one that says your sample mean is close to your population mean if the sample's big enough or something. I don't know. We don't really use that one as much, so I don't know as well.
Yeah, so that one isn't that the one that like
The more numbers there are, the mean.
bigger or something? Or closer together? Yeah.
Yeah.
Okay. Just wanted to make sure because I get them confused. All right. So the researchers, sorry, other one. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
I vote B.
That's what I was.
Mhm.
Wait, why?
Because we don't know the population, because we don't know how many males and females there are. But we do know the mean.
Where does it say that?
And it's not like we're seeing a difference between.
Just a huge thing that Zuri read. It says information, and it gives like a huge case study before question 3.
Yeah, so, but, wait, explain.
So they're just conducting a test for one crop weight.
What?
No, it's not B, because they want to see if the reaction time is different from males and females. So it would
So-
It
be
doesn't.
a confidence
but,
interval for the difference of means.
Mhm. C, right?
That makes sense.
Yeah.
Would it be independent samples or dependent? Because
I think they're independent because
they don't
Because
have
with-
to relate, right? Like one doesn't have to lead to the other. What?
I'm not gonna
they're
talk.
not like they don't have anything to do.
Sorry, guys.
Ashlyn, you can talk. Go ringleader.
No, I can like delay, so I'm like saying something, and then it's like someone's already talking with a great idea, so I'm really sorry.
And I'm just enjoying.
Can you get her closer to the something? Because I'm having a hard time hearing her. I cannot hear her. Maybe it's just me because I'm.
I'm gonna be real honest. I don't even know where my speaker's at.
I'll turn it up. I'll turn it up in my computer.
I'll just...
It's okay, really, just leave me there, and if I have something really important to say, I'll just tell you, okay?
Oh, there you go. But I turned it up. I think I can hear her now, wherever you put her.
Just
Number 5.
Number 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be those 2 numbers. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Like more bank customers, right?
Yeah, D.
Mm-hmm.
You increase the sample population?
Yeah, that's the law of large numbers. That's what we were talking about.
Mm-hmm.
Okay.
Brittany went like this.
Thanks.
You're welcome.
All right. So a factory makes four-color drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their mean to be 100 millimeters. Lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate the 95% confidence interval for the true mean length of the shafts. For the margin of error, lower bound and upper bound. Great.
Oh, it's 1004 and 996.
Why?
What?
'Cause you
Right?
you multiply the standard deviation by 2, and then you add and minus it from the mean. So that makes the confidence intervals.
Why do you multiply by 2?
Wait.
So you know the 68, 95, 99.5 rule?
Yes.
Or I don't know what the number is, but 95% is 2 standard deviations out both ways.
Oh, I see what you're saying. So we have 4 minus, so 1,000 minus 4, and then 1,000 plus 4. Is that what
The
we're
margin
doing?
of error is 4.
So what's the margin of error though?
You have to do
It's
that.
4.
What?
4.
Remember, because it's just how far the mean is from one side of the confidence interval.
So the margin of error is 4?
Yeah.
How do you get that again? I always get that one wrong in every single quiz.
You subtract the upper level of the confidence interval by the mean. So it'd be 1,004 minus 1,000, which is 4.
Oh, okay.
So the lower bound is 996.
Yeah.
And the other
Unless I'm taking it wrong and I did it not.
There's a formula, but it's not giving us what we need.
The formula for finding the confidence interval?
No, the margin of error.
Oh, yeah.
I don't have
I don't know how to use it.
but she just taught it to me. I have it on my other notes, but I don't have it here.
It's just z times the standard deviation over the square root of n. But we don't have n.
Yeah, we don't have the population.
What?
Right?
I didn't hear what you said.
Oh, I said so we can't use it.
I don't think so, no. I think it is just 4.
But we can use the 6895 thing rule, right?
Yeah, totally.
I think that's easier than using an equation anyway.
Yeah.
Please.
Okay, number 9. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighted at a total of n times, and the mean of the weighting is computed. Suppose the scale readings are normally distributed with a known mean u and standard deviation 0.01 grams. Now, how large should n be so that a 95% confidence interval for u has a margin of error of 0.0001? 0.0001.
Okay, this is the formula. N equals. Oh, geez. I'm going to show you guys. I'll show you in a second, Ashley.
Okay.
I got to circle it because I got a lot of notes. Okay, you see this one? Circled?
The n equals z sigma over m squared?
Weird, yeah.
Oh, yeah, I remember
Yeah.
that.
Okay. You see it?
I literally don't remember this one at all.
This was like 3
So,
weeks
n
ago or so.
equals, oh my goodness.
This is okay. I got it. Thanks. This is to find when the mean is unknown.
No, the sample
When
size.
you want to, when the sample size is unknown.
Z sigma.
Did you guys get it? Can I put it down?
Yes.
Yeah.
Thanks.
So would we just,
Wait, but isn't n unknown? I'm confused.
yeah, so n is what we're looking for.
I know,
N
but
is the margin of error.
what's n?
Margin of error, isn't it?
Margin of error, yeah. If it was looking for the mean, it would give you that like little U symbol.
Yeah.
So they're asking for 0.0001 for the margin of error. So that's what you plug in for the M.
What do you point it for Z?
Isn't that like 1.096 or something?
Yeah,
You just
so
use the app.
It's 1.96 for 95% Carnot. You should write these down. So 90% is 1.645.
Hold on. So I need this.
Because you're going to want it for the test.
Yeah.
So 90 is
90 is 1.645.
Yeah. And then 95% is 1.96. And 99% is 2.58.
2.58. Okay.
You.
Thank
So
you.
I'm going to do 1.96 times 0.01 divided by 0.0001 and square it?
Yeah.
Holy crap. Did I do this wrong?
Whoa, did you guys get 38,416?
Yeah.
Yeah.
Okay, but look at the margin of error, though. That is a crazy margin of error.
Yeah.
Yeah.
Wait, hold on. Did you guys do 2 times 0.01 divided by 0.0001?
No, it's 1.96.
Well, was that a Z or was it a 2?
Z, sorry.
It was a
Oh, it's 1? Oh,
The Z is like, remember how they like gave numbers for like,
Yeah.
yeah, so it's just,
oh, so it's 1.96 times 0.01
yeah,
over 0.0001 squared.
yeah.
So we actually think that's the answer?
I think so. To get a margin of error that small, your sample size would have to be like massive.
Yeah.
It makes sense.
Just to make sure you guys got 38,416.
Yes.
Wait 1 second.
Hey. Oh.
I want donuts. That sounds good.
I would eat a donut anytime.
38,416.
Yeah.
I would not eat a donut considering that I just ate so much candy.
I
Oh.
can't. I'm
I
like,
have cupcake.
that's not good. I have brownies. I made brownies the other day, but they're like hard now because I didn't eat them quick enough.
That's
Okay.
not a problem.
I can do number 10 now.
Ashton says she's good. We can do number 10 now.
All right. The main area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses that are
Isn't it the last one?
yes. No, wait.
I think it's. Oh wait. Yeah, it's the last one.
Yeah.
We should, never mind.
Yeah, because they think it's less than.
Yeah,
And
it's the last one, definitely.
For sure. All right, 11. In a statistical test of hypothesis, we say we reject the null hypothesis with the level of significance of alpha if the
P-value is
larger, right?
Less than.
Yeah.
What?
It's
we
less than.
reject than alpha.
Yeah, you're right.
Oh, if we reject, not fail to reject, you're right. I'm telling you, I get confused with those two. I gotta write them down. All right. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPS from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data of each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question?
Yes.
I would say.
Okay.
Wait, if it says the sample variances are nearly equal, Is that not enough?
I think
Do
it
they
is.
have to be?
I think they can be just like close, right? Like they don't have to be equal.
Yeah, because the ones we were doing yesterday, they weren't equal, but they were super close.
Yeah.
Okay.
So C.
What?
C. What I see. Okay.
Yeah.
What do you guys think?
I think it's C.
Yeah, I also think it's C.
Yeah.
Because I don't really know why the central limit theorem would have applied to it. Isn't it just because you need a various different, like, they have a total of 60 QPAs, but isn't the ANOVA, isn't that like when you're testing different samples, like different mean samples?
Yeah, it is. So the central limit theorem would only apply if all of those samples had enough data. Like if they were all big enough,
Yeah.
not combined.
Gotcha.
I put C.
Me too.
Mhm.
Yeah, me too.
All right, so 13. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. What type of error does she have? Or not? Does the researcher has?
A type 1 error is when you have rejected the null when you shouldn't have, right?
I think so.
Yeah, so it's a type 1 error.
Is there an easy way of remembering this? Because I always forget, like I never.
Null is what we always want to come first. I don't know.
The null always comes first when we write it out.
Okay.
So type 1 error is the incorrect rejection of a true null hypothesis.
Yeah.
So it's a type 2 error.
And type 2 is incorrectly retaining a false null hypothesis.
No, this would be a type 1 error.
Yes.
So,
Does she rejected the null hypothesis, right?
she rejected the null hypothesis.
Yeah.
Okay.
So the new treatment does not increase the mean. It does not increase the mean survival time. But she rejected it.
Wait, Ashton, do you still have the definitions up still?
Yeah.
Will you reread them?
Yeah. So in statistical hypothesis testing, a type 1 error is the incorrect rejection of a true null hypothesis. So it's like also known as a false positive. So like when you find like a false positive, doesn't that mean like when it says it's going to work, but that's not true? So that's like, yeah. So type 1 is when you incorrectly reject the true null hypothesis. And then the type 2 is when you incorrectly retain a false null hypothesis.
So if you were like the type 2 error, if you were to get a, like in this case, if the after several, like the 4.5 years after the sample or whatever were to be true, and she said, no, that's not true, then that would have been a type 2 error, right? I'm sorry, I made that confusing. Never mind.
I don't know what.
You'd have to ask Ringlander number 2.
The question, like the wording of it, kind of confuses me.
Yeah.
Okay, I'm just gonna read it over again slowly and try. So the average survival time after diagnosis for the standard treatment is 2 years.
Mhm.
So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. So the null hypothesis is that they're equal, right?
The 2 years, yeah.
So then in an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at that level. Consequently, rejects the null hypothesis. In the future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer.
So it's a false positive.
It's a false positive. So she rejected it even though it was true, right?
Yeah, because she didn't have a big enough sample size, so it's a type 1 error.
Mhm.
Yeah.
Wow, that one was way harder than it should have been.
Yeah,
Yeah.
this is the wording that's confusing.
It was just a very long and intimidating problem.
Yeah, it's just too wordy.
Yeah.
Okay, 14. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
A.
Well, I have this written down somewhere, but I don't have it with me.
I think it's A.
You just, yeah.
We increase
Right.
the probability of a type 2.
Yeah, that would make sense.
Woohoo.
See, that one was easy.
All right, 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean U and a known standard deviation 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content actually higher than advertised? To answer this, test the hypothesis that the null hypothesis is 1.5 and the alternative is the mean is greater than 1.5. At the 0.05 confidence level, you conclude that you should.
I have to read this by myself again. I don't know.
You're good.
There's a 5% chance that null hypothesis is true. That's true, isn't it?
I don't know.
I don't even know.
I don't.
There's a 5%. No, that's not true.
No, that's
Because
not true.
it's a 95% chance.
Jeez, Brittany.
So do we have,
Nothing.
do we have to find Z then?
I think so.
Yeah. I don't remember that equation.
Why did she say that?
We have to find the Z-score.
I don't remember that either. Isn't that the way?
I'm Googling it.
First. Z equals
X minus mean over standard. Did you say mom?
No, I said no to my husband.
X minus value?
Z X minus mean over standard deviation. I don't remember what the X stands for though.
Oh,
Yeah, page. Ashland's Ringleader 1.
it's question 15. It's just 1.53. Right? because that literally is x.
1.53 minus 1.5
No.
divided by 0.17. Or is it 0.17 divided by
No. It's deaths. Actually,
what?
let me look at the thing again.
Do we have to do the thing where you do the
Guys,
sample?
I'm like so discouraged. This is only test number 2.
How many tests do we have to take?
4.
I think I'm going to the exact same point, Ashlyn. I like have no motivation whatsoever.
So it's which one is the U and which one is the X? Is the U 1.5?
Yeah, the U is 1.5 and the
Okay,
X
so
is
it's
1.5.
1.53 minus 1.5 over 0.17.
Over.
But is it 0.17 or is it 0.17 divided by the square root of 100?
Oh,
You know how you find the sample standard deviation for some of
Oh,
them?
you're right.
I think just to find the standard z-score, it's just the standard deviation, not, you don't deal with the population.
Oh,
So it's okay to just divide it by 0.17.
yes.
that's what the formula says. If that's what
Bum.
X and U are, then
I got 0.17. Well, 0.18 if you round up. 0.176.
Yeah, x minus mu over the standard deviation,
Oh, yeah, me too.
which is 1.53 minus 0.5 divided by
1.8, which means we reject
The null hypothesis.
the null hypothesis.
What did you guys get?
0.176.
Yeah.
point what?
176.
Then why are you rejecting it? It's higher than the level of significance.
I mean, we failed to reject it.
This is why you're ringleader number 2, not 1.
Wait, sorry. Level of significance is 0.05 and it's higher, so you failed to reject.
Yeah, don't listen to Brittany.
C.
Don't listen to me because I will lead you astray. I'm the devil sitting on your shoulder.
Oh, wow. Alrighty. 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure?
ANOVA. Oh, I made that up.
It's an
Technically, it would be 2 subject thing, wouldn't it?
Is it?
independent samples t-test.
Yeah.
Yes.
B.
What is it?
Independent samples t-test.
Because that's the one that makes more sense out of everything.
Why? Can you guys?
Yeah.
Why? I don't know these at all, and I am just banking on the sheet that she gave us.
So it's not the z-test because we don't know the population. So it has to be a t-test. So that's the rest of them. And it's not a paired because the male and females, it's not dependent upon each other.
Mhm.
And then it's not one sample because we need to take 2 samples, the males and the females. And ANOVA is just sketchy. That's how I worked it out. So
Why is it not a?
ANOVA is more than 2.
You need 2 samples.
no, well, that too, but the z-test, you need to know the whole population.
Oh, instead of just a sample.
Yeah. Well, like they're just doing male and female students. So we don't know how many male and female students there are in the United States.
It doesn't give us like the population mean and the population standard deviation.
Mhm.
You'd have to have that for a z-test.
Say that again. I couldn't hear you.
To have a z-test, you need to know the population parameters, so like the standard deviation and the mean.
Have a Z-test.
Yes.
Perfect.
All right. We good?
Yes.
17. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. You should use a hypothesis test based on independent or dependent sampling.
Dependent.
Dependent.
Because it depends if they're standing next to each other in the birth line.
D,
It's D.
Good. All right. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded in the dissolved organic carbon file. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for the situation? Opening this file.
I don't get the question.
We have to move the information to the thing,
What'd you say?
right?
I think
Yeah.
it's A.
What?
It's either A or B.
Oh.
'Cause
It's not a
asking
difference of
for-
mean
Well, it is in
percentage,
19,
set.
but just in 18, you don't have to really.
It's A, because it can't be B.
Yeah, that's what I thought, but I was throwing it in there just in case.
It had to be a t-test, right? That's why it's that.
Yeah.
How do you guys know
Is it-
that?
A t-test is when you don't know sigma, like the standard deviation.
Oh, you guys put it in a T-test form?
No, it's just what it says on the thing.
Inference.
So it says what? Go for it.
No, go ahead.
So it says that it doesn't like give a population, so we know that it has to be a t-test, but like since it's a t-test, we know that the sigma is unknown, and so it makes it a confidence interval for the mean is when sigma is unknown.
Okay,
Easy peasy lemon squeezy.
perfect.
All right. I'm just putting, okay, there you go. All right, so which of the following is the 95% confidence interval for this analysis? Margin of error.
Do we have to put in the null hypothesis for this?
I think so.
Will it change it?
The margin of error? I don't think so. It changes the
I
p-value.
don't know. I just don't touch it.
It changes the p-value.
You just said don't touch it. Is that what you said?
Oh, that's what that guy
I think
said.
so.
Is it greater than or is it, what did they say?
I don't think we need that for number whatever we're on.
Oh, you're right.
19.
Did you guys get 2.025 for the margin
I
of
got
error?
2 point. 0.024.
Hold on. I want to do this.
Well, don't you round up?
That's like exactly what I got. I didn't get anything else.
Wait, how do you get that again? You just subtract all the intervals, right?
15.217 minus 13.193.
13, you said?
Yeah, so the highest
You do upper
bound,
or lower.
you can do either, but I always use the higher bound of the confidence interval.
Mhm.
Subtract it by the mean.
Oh, by the mean. That's why I was getting it wrong.
I still got 2.0245.
5?
That I got.
Yeah.
I got 2.024.
That's what I got.
Why did I only get 2.0?
When I talked to our teacher, she said to find the margin of error, you do the upper minus the lower divided by 2.
It's the same thing as doing the upper minus the mean. It gives you the same number.
It does? Okay.
I'm going to put 2.025.
But I can try doing it that way too.
Well, you can put it in the other way. I think we get 2 attempts on this
I
one.
mean,
Just like
even if you did the upper minus the mean, it would be 2 point. Hold on.
Yeah. So
Yeah, it does give me the 5 when I do it the other way.
that's the same. So should we just put 2.025?
Yeah.
What are you putting in page again? What did we say?
2.025. And then the lower bound and upper bound.
You mean on the margin of error?
Yeah, and then question 20 is the lower bound and question 21 is the upper bound.
Okay.
It's asking for the lower bound.
Oh.
Lower. Round to 3 decimals. Did you guys put 11.168?
Yeah.
Yes.
15.217.
Whoa. Hey.
Okay. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded in Ms. Hammers. Why in LA? We want to know if there's a difference in listing prices between Hummers for sale in Los Angeles, that's the group 1, and Hummers for sale in New York, group 2. Rate the 95% confidence interval for the true difference of mean listing prices between the two cities.
Confidence interval for the difference of means using independent samples.
That's what I thought.
Because they have nothing to do with each other.
Yeah.
Wait, what did you put again?
C.
See?
Alrighty.
Bad.
Okay. And now calculate the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and then Y. Input your answers. Okay.
We're looking at the price, right?
Yeah.
It'll be the 2 sample t-test, correct?
I think so, yeah.
Okay.
Paired sample, right? Just a 2 sample t-test?
Sample.
Yeah.
Because a 2 sample t-test still finds the difference.
Wait,
Yeah.
so you're not doing the 2 sample t-test?
No, you are.
Oh shoot, I did this wrong. Dang it.
How?
No. Okay.
Whoa, guys, I got a negative for a confidence interval. Is that even allowed?
Me too.
Really?
Yeah, they do that. Uh-huh.
What did you get? I got negative 423.238.
Yeah, that's what I got.
Same.
For the confidence interval, do you say?
Yes.
Yep.
Okay.
And then the upper one, did you get 5417.336?
Yeah.
What do you get for the lower one?
Negative 423.238.
It's just my Excel freaked out again.
I feel it.
There it goes. Okay. So negative 423.238, correct?
Negative 423.238.
Yeah. For the lower bound, and then the upper bound is 5,417.336, correct?
Yeah.
Okay. All right. So use the following information. Okay. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. A control with no jumping, a low jump group, and a high jump group. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The data was recorded in exercise bone density. Researchers would like to determine if the mean levels of a bone density are different between the 3 different groups of rats listed below. Use a 0.05 level of significance. All right. What is the correct hypothesis for this situation?
Nova.
Nova.
ANOVA. Calculate the best statistic. Divide 2.
I got 7.978.
You're quick.
Already? Yeah, dang
Yeah.
it.
Wouldn't it be an F statistic that they're asking?
Yeah. That's what I did get for that.
What? Let's see. How,
Hold on.
it's funny because you're already done and I'm still copying and pasting.
Same.
That's okay. I'm just trying to do a little bit fast because I got my class.
Oh, sorry. Okay.
But it's okay. Take your time. I'll just
No,
get my
I got it. How do you get the test statistic again? That's the T one, right?
Yeah, but in
It's that-
a Nova, it's an F.
Oh, it's the F statistic. You're right. Okay. All right, that makes sense. It was 7.978, correct?
Mm-hmm.
All right, and then the p-value was 0.00189.
I'm going really slow, so I'm sorry.
That's okay.
Really?
I rounded it up, Zuri, so it's 0.00.
0.002.
7.978.
We can wait, Ashlyn. It's fine.
No, I got it. Sorry. I'm like not working on my normal computer, so I'm like trying to figure this out.
Oh, that's always the worst. I hate that.
The p-value is 0.002.
Yes. Yeah. So we reject the null hypothesis?
Yes.
There is sufficient evidence to conclude
That.
that the mean bone density of at least one of the groups is different.
Mm-hmm.
B.
C.
D.
Oh.
Wait, C?
It's D.
1, 2, 3, 4. D. Yeah.
D.
All right.
Wait, D?
You're good.
Oh, yeah. There's an E. Dang.
Yeah.
Wait, it's the last one, right, guys?
This one is definitely the last Excel thing.
Yeah.
No. Number 28. What is the answer?
Oh. D.
The fourth one.
There is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Sorry. Everyone's like E. There's an E. A D. Is it B? I don't know what's going on.
Oh, there's one more. Okay. Pressures of supply and demand act directly on the prices of an airline ticket. As the seats available in the plane begin to fill, airlines raise the price. If seats on the flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for a scheduled flight 90 days in advance and then 14 days. The data was collected in the drive.file. Perform a hypothesis test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 0.10 for the next 4 questions. Do 14 days and then 90 days for the analysis.
So it's paired.
Dependent.
Yeah.
Dependent samples.
Yeah. Independent. Right? Yes.
What?
Dependent.
Dependent.
Independent. Okay.
What are you saying? I didn't hear.
Zuri said independent, and then Brittany and I said dependent, not independent.
Right.
All right. Guys, why is this such a hassle?
It's just a lot. I feel like we're taking that test.
Does it?
This should have. Yes.
So we're supposed to do 14 days minus the 90.
Yeah, I think so.
Yeah.
I think my Excel is frozen. Oh, there it goes.
Mine is still loading. Loading.
Oh, this is so frustrating. It is so slow.
I hate that. Goodness gracious.
Okay. I did it. The T. 1.670.
I got 1.685.
Really?
You guys.
All right, you guys' stuff needs to work.
Yeah. Come on, guys.
Hold on. I'm going. Give me just 1 second.
I'm like waiting for it to move and it's not.
We're gonna input it again, okay?
Okay.
Like it's loaded.
This is the
And then
previous
I
one, right? So got the difference here. And
Do
then
it.
I got the 90 days. I'm copying the 90 days that are very, very long.
That's what I'm trying to do, but it won't let me.
Then the 14 days. Oh,
My goodness.
what a joy.
I can't do this.
Okay.
I still get 1.670.
Okay, for what? For the
I
T?
don't know. What did you get?
For the T, I
But-
got negative 1.636.
Well, that's not what I got at all.
That's not what I got either.
I don't know. I got that number. That is weird.
To delete that and reopen it up again and do it.
No. Oh, I see why. I see why. That's annoying.
Why?
I subtracted 90 minus 14, not 14 minus 90.
Ooh, okay. So what is it? Did you guys get 1.685?
That's what I got.
What? How?
I put it into the thing.
I know, but I did too, and I'm mad. But
I did 14 days minus 90.
What?
I did 14 days minus 90.
Yeah. Yeah,
Yeah,
I did
I
it
messed
again.
that up.
I got the p-value as 0.096.
Oh, okay, mine just switched. 1.685.
Whew.
Okay, I'm gonna trust you guys.
Six.
This is gonna be a hassle if I try to do this again.
Okay, so 30 is 1.685.
Okay.
And then I got 0.096 for the p-value. Is that what you guys got?
Yeah.
Okay.
Okay, which one best expresses the conclusion of this test using a 0.10 level of significance? There is sufficient no, yes.
Well,
No.
it's lower than it, so we reject the null.
Reject the null.
We failed to reject. No, we reject the null hypothesis.
Mhm.
So there's,
Means that it's sufficient evidence, right?
I think it's B.
yeah.
Okay, I'm going to
There's a
submit.
Okay.
How many did we miss?
I hope none so I can go to class. Dag flabbit.
How
We
many?
missed 3.
3.
I gotta find it. We missed question 15. Question 8, question 7, and question 6.
Ooh.
So that's 4.
7, 8, and 15?
Yeah.
Yeah, it was that margin of error one, remember?
Maybe we should have done the formula. Oh wait, but we
No.
can't.
So I remember doing this by myself, and I got something. Or those are the ones that we missed.
Yeah.
So
Wait,
I
number 3?
I did it like the 95% confidence interval. Oh wait.
What were the ones that we missed again? I need to write them down. So
6, 7, 8, and 15.
6, 7, 8, 15. Okay.
So are we starting with number 6?
Okay.
Hold on. I'm going to go to this. Where's the review questions? If you go to number. Is number. Oh, hold on. I'm trying to find it on the review questions for example.
Oh.
Yeah. Oh yeah, so it's the same as number 5. The question number 5. And I mean, at least this is what I got. Like,
What did you get for the answer?
Well, no, I'm trying to see if it's like the same type of question.
It is the same type of question, but it's not number 5, it's number 6.
Yeah. So it's asking for. Oh.
Sorry, guys.
The lengths are known to follow a normal. The standard deviation is 2.
Wait, I'm so sorry, but I have to tell you something. The kid totally wiped it out on his longboard outside my window.
Sorry, just one moment. Want to check that I'm not like burning on fire or something.
So, okay, guys, I don't know if this is right, but one confidence interval, the 95% confidence interval from the true mean is 1.96. So, don't you just do 1,000
point.
plus 1.96, 1,000 minus 1.96?
What did you get? But it was
Or time.
That's
There's
right.
a margin of error.
I don't know what's going on.
Is that your apartment?
Zuri left. She had to go check it out.
So, okay, so 95% interval is the z-score is 1.96.
Okay. It stopped, guys. I'm sorry about that.
Right?
Oh, I'm sorry. I was still looking at the longboarder and listening to Zuri's alarm. There's too many things going on. Sorry.
Yeah, I apologize.
I
I don't know. You should have muted me. I'm sorry about that.
But how do you guys remember the formula? Because there's a formula for finding the margin of error. And maybe we're supposed to use 1.96 instead of the 95. You know what I mean?
It's z times the standard deviation over. I can't remember. I put my notebook away.
Oh, wait. Do you have to have n?
Yeah. Yeah. So it's z times the standard deviation divided by the square root of n. It looks like an n, but I don't think we had n, so that's why I didn't really do it.
We don't. That doesn't make any sense.
Sorry, I don't even know if you guys
the
said
sample mean. It's 4. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000.
Oh, hey!
So it would be 1 point. Wait, we're doing a 95%, so it'd be 1.9 times what?
1.96.
1.96 times 2 divided by the square root of 4, which is just 2, so it would be 1. So it's 1.96, just like you said, Ashlyn.
What?
Wait, but so you do 1.96. Which what's the formula? Sorry, can you read it out loud to me? Just like the z.
Yeah, z parenthesis.
Yeah.
The sigma or standard deviation symbol over the square root of n parenthesis.
Okay, so it's 1.96. Standard deviation. What? Oh yeah, times 2. Oh wait, divided by the square root of n, which is 4 square. Oh, which is 2. Oh, it's 1.96. Yeah, that's what I thought.
Yeah, I was validating you.
Oh, so that's the margin of error then?
Yeah.
Yeah, that's what I thought. And then you just added 1,000 plus 1.96 for the upper bound, right?
Yeah. And then 1,000 minus 1.96. That's the lower bound.
So the upper bound is 1,001.96. 1,001.96. and the lower bound is 998.040.
Yeah.
Lower bound is 99.
Wait, did you guys submit the test? Am I the only one that submitted the test?
You're the only one that submitted the test.
So we can don't submit it, so we can check.
Number 16 we also got wrong.
15.
15?
Yeah.
Oh.
Wait, hold on. Sorry. Could you say the lower bound and the upper bound again?
Yeah. So the lower bound is 998.50, and the upper bound is 1001.96.
Oh, I see why. Okay.
So number
Thank
15.
you. 15. Huh.
Fail to reject null, right?
Yes.
That's what we said, but we missed it.
Maybe we reject the null hypothesis. I don't know why, but let's just say we do.
Here, I'll test it.
You think we do?
Make sure it's D, not the one with the A.
With the other
Yeah.
one. Yeah.
So 15 is D. That's what we say.
And everything else is okay, right?
Wait, don't put it in. Brittany's gonna be our guinea pig.
No? Okay. Cross your fingers.
My computer's really slow, sorry.
The suspense is killing me.
Guys, this is gonna be fun to watch for Sister
yeah,
Wilson.
right.
Yeah?
What?
You reject the null. Yeah.
Okay. Ooh.
Yep.
This was long.
Yeah,
Mhm.
telling me. Hey, would you guys do me a favor and read the answers again?
Wait, did you
Yeah.
get
Did you get 100, Brittany?
Yeah.
Yes.
Oh man. Sometimes I click them and you know how to let you change it?
Yes.
I hate that because I just did that on one of them.
Oh,
And
wait.
lets you change them? Oh.
After you submit it and you click on another multiple choice question, it'll move your little bubble.
Oh.
Oh, you guys, I am such a fool, and I accidentally put in the. I have to redo it.
Me too.
Okay.
Hold on. I'm getting it.
I've got it ready.
Okay.
Okay, number 2 is B.
Oh.
I messed up.
Already?
I got one wrong. Hold on. I don't even know which one I was stupid to put wrong.
Okay. Number 1 is true.
Mm-hmm.
Then it is
Good job.
B, C, C,
Mhm.
D, 1.96, 998.50, and 1001.96. Then 38,416, and D, B, C, A, A. 15 is D. 16 is B. D. Oh, wait. What number is that? 17? 17 is D. 18 is A. 19 is 2.025, right, Brittany?
19? Yeah, 2.025.
11.168. 15.217.
Wait, Brittany, or sorry, Ashlyn, I think you put in question 7 the wrong one.
I did as well.
What?
I got
7 isn't 998.56 was it? It's
Nine-
not.
8.56.
Number 7?
Yes.
Yeah, it's 998.04. You're gonna get that wrong, Ashlyn, if you put it in that.
I didn't hear what she said. I thought she just said 998 and then moved on to question 8.
No, she said 998.50, and then I got it wrong. So I'm just letting you know.
Oh,
Oh my gosh, did I do that? Really?
Yeah, it's fine though. I don't care.
What is it? 998.04?
Yeah,
Okay, good. Because, yeah, I got that one wrong.
yeah. Hey, I'm gonna step out of the room really quick.
Oh, you can hang up. It's okay. I'm good.
No, you can keep doing it.
Okay.
I have to ask my roommate to see if they'll get me right. So
17 is D. 18 is A. 19 we already did. 20 we already did. 22 is C. 23 is -423.238. 25 is 5417.336. Then 25 is a nova. 26 is 7.978. 27 is 0.002. 28 is D. 29 is dependent. 30 is 1.685. P-value is 0.096. 32 is B. Let's hope for the best. Yay!
all right, guys, I really gotta go. I'm so sorry.
All right, bye. Thanks.
Bye.
oh, okay. Well, see ya.